Okay guys, video number 2 on how to change a product to a sum. We're going to try some more of these. I hope you watched the last video and kind of have the hang of it a little bit. So we're going to try some problems. Here is problem number 1. We are going to turn x plus 3 times x plus 1 into a sum. That is our problem. Now, we're not solving for x yet. I said this in the last video. We are not doing any solving yet. We're just rearranging how it looks because later on that is going to help us solve. So right now it's in product format. Product means two things being multiplied together and we just want to change it to a sum. So we think of it in our class as kind of like having a length times a width, two dimensions being multiplied. And what we're going to do is we're going to find that area of that rectangle. So it's another algebra tile problem. We're going to use our tiles to build this thing. We're going to build x plus 3. So I'm going to grab an x tile in 3 little units. 1, 2, 3. There we go. And then we're also going to need x plus 1. So I'm going to get another x and a plus 1. And we're going to build a rectangle with these dimensions. So watch, I'm going to stack it like this. Here's my x plus 3. Make it look good. There we go. Here's my x plus 1. That's my length and my width. I need to fit a rectangle inside of this space. It's kind of like this. Let me show you. Sometimes it's hard with the tiles, but I'm going to try my best to show you this. I want to fit something inside of here. So it's as if I took the top edge up here, went across, went up. I want to fit within that space. So now our job, the challenge, and this is what you're going to be doing on your own in class without my help, is you got to pick which tiles you want to use that will fit perfectly like a puzzle into that rectangle. It has to be a perfect fit. And so this is the puzzle part of this problem. Pause the video and try it yourself. See if you can do it. Okay, so I'm unpausing the video, hopefully you are, and we are going to see what fits perfectly into this shape. So I'm definitely thinking an x squared fits like ideally right there. I'm also thinking for this long skinny spot, like an x would work perfectly. Look, perfect fit. And then on top, I have to kind of think about this a little bit. Even though there's like these little units here, I'm kind of seeing it like this. Like, okay, here's an x. Yep, there's another x. That's a perfect fit. And then if I go like that, oh, look how nice. Look, I could fit 3 little units probably spot on into that location. So let's see, I'll flip these over. Let's get 3 of these in there and make sure it fits perfectly. And it should. And it does. There we go. So, sweet, there's our rectangle. So if I pull back my length and width, these were just the dimensions. This is what we have, a full rectangle. Now the area of this rectangle, I see an x squared. I see x, 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 so I see 4 x's and 3 little units. So I see x squared plus 4 x's plus 3 units. And we just found our answer. Now, one of the things we're going to do is after we build it, because this is the part where we built it, we're going to draw it. And you're going to see in some of the classwork that we do that you're going to be asked to build and draw. So over here I'm going to label that this was the build part, right there. And over here I'm going to do the draw part, where I draw the picture. Now, I like to draw the picture like this. I don't know why, but I think it's simpler. I draw like a corner, and I say, okay, this is the length, this is the width. And remember what our length and width were. It was x plus 3, so over here I'm going to draw an x plus 3 little units. And I don't make it a perfect drawing, I'm just kind of trying my best. And then on the bottom it was x plus 1, so x plus 1. And I probably will just sketch on the outside that we wanted to fit our rectangle within these dimensions, inside of that space. So I like to just basically take the lines where the tiles are broken apart and continue them across my picture. This is kind of my strategy. And there it is. We've got a big x squared, matches this one over here. We've got an x, 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 and then 3 little units. And we've got our picture to match our built algebra tiles. So take a look at the screen here, take a look at your work. This is exactly what you want it to look like. It's labeled product and sum. It's built, nicely done. It's drawn. So you have all the components. Now we're going to do one more in this video before we're all done today. And then in class you're going to have to practice and use those algebra tiles when you have an opportunity. So problem number 2 that we're going to do today, number 2, is we are going to take a new product. We're going to take 2x parentheses y plus 1. And we're going to take this and turn it into a sum. Now this is different than any of the other ones we've done in the video so far for 2 reasons. One, we're finally using a y, changing up the variable a little bit, but also because in this product there's only one parenthesis, and that's because you really don't need both parentheses when there's no adding happening here. There's just a 2x. It's not like it's 2x plus 3 or 2x plus 5. There's no plus anything. So sometimes we drop the parenthesis and we don't even use it. But technically it's the same as this. So I still see my length and my width. So what I want you to do is I want you to pause the video and see if you can completely solve this one on your own and get the right answer. Because if you can, then you know you're ready to kind of practice in class. So go ahead and give it a shot. Okay, so I'm hoping you're unpausing the video. We're going to check answers now. So our length is 2x, so I'm going to put 2x right there. Our width is y plus 1, so I'm going to have to get that long purple y tile plus 1 little unit. And I'm going to put that down at the bottom down here. Let's see, let's get a nice fit here. And now we got to find tiles that fit within that space. So this is going to be one of those scenarios where I think right here we're going to have to use that Christmas green colored tile. So we want this tile, the dark green one. It's going to fit, look, it's going to be a perfect fit right there. I hope you figured that out on your own. And I'm going to do 2 of them like this. And then I still have this long strip on the side, which I think we're going to have to use X's for. Look. Yeah, look at that. That's going to be our perfect fit, is an X and an X. There it is. There's our rectangle. I'm going to pull the length and the width back off so I can see it. And we've got our answer. These tiles are called the XY tile, and we have 2 of them. So I'm going to write up here we have 2 XY tiles. Plus, we also have these X's, so 2 of those, 2 X tiles. Then we've got our answer. And we've built it, and we've labeled it. It's labeled up there, product and sum. The only thing left to do is to draw a quick sketch of what it looks like. So there's my corner. Oh, my drawing's a little messy, but that's okay. Over here, I'm going to label that we used an X and another X. 2 X's for the length. And then for the width, we used a Y tile, which was a little longer, and a unit tile. So we had to fit our rectangle within this space. So using the strategy that I like to use is just draw the lines across where the tiles split apart. And here we go. We have an XY tile, an XY tile, an X, and an X. And there's our picture. Alright guys, well I hope with a couple of these videos you know how to switch a product to a sum, specifically using your algebra tiles. We will not always use these. Eventually we're going to drop the tiles and do it without. But it's good practice to be able to put that puzzle together and figure it out. Thanks for watching guys, and look for the next video.